Now I want to look at the Goldleaf Electroscope. The Goldleaf Electroscope is a device used for the detection and testing of what? Charges. You use this Goldleaf Electroscope to detect the presence of charges. Then you use it also to test the nature of the word charge, whether it is positive or whether it is what? Negative. It consists of a brass cap. Look at the brass cap here. It's labeled metal disc or brass cap attached to a brass rod. You can see the brass rods here. This is the brass rod here. This is the rod itself, which is brought out here. It's known as the metal stem or brass rod. It consists of a brass cap attached to a brass rod, that is the stem, and a gold leaf attached to the bottom of the stem. This is the gold leaf. This is the gold leaf attached to the what? The stem, as in the diagram was below. So you have here as the Goldleaf Electroscope. You have here is earth connection, but it is always earthed. You have the glass window, you have the metal casing, and then what you have here as insulator, then you have metal disc or brass cap. You have here as the rod, the brass rod or the stem, and then one here is the brass plates, then or the metal plate, or then we have here the gold leaf itself. You have it the same thing, or it is also just brought out here for clear labeling. So you have here is the gold leaf. The leaf is surrounded by a drought-proof metal case with two plain sides glasses. Two plain side what? Glasses. You can see them. This glass you see is also found at the back of it. So while within the sides here, you now have a metal casing. It's surrounded by a drought-proof metal case with two plain side glasses so that the leaf can be easily seen. So with the glass material here, you can see the leaf clearly. The case is earthed, that is connected to the earth to prevent any accumulation of charges due to external influences other than that of the wall cap. Note that any charge coming in, if you place a material that is charged on the cap, it will flow from there to the what? To the rod. Now you have it that this material, this case here, it is earthed so that it will remove any charge coming again apart from here, so that it will not accumulate more charges. It is always earthed, connected to the word earth. Is that okay? So the case is earthed, that is connected to the earth to prevent any accumulation of charges due to external influences other than that of the word cap. Now, how to charge this electroscope? Positively or what? Negatively. We can charge it either positively or negatively. How can that be done? This can be done by electrostatic induction. By what? Electrostatic what? Induction. It is a method by which a neutral body, example the electroscope, is given a positive or a negative charge by bringing it near a charged body as illustrated below. We have talked about electrostatic induction today, but now I want to see how we can use this method to charge an electroscope positively or what? Negatively. A, to charge an electroscope positively by electrostatic induction, follow the following steps. We want to see the steps we're going to follow now so as to charge this electroscope we have seen before now, how we can charge it so that it will have only positive charge or only negative what? Charges. Now bring a negatively charged ebonite rod close to the cap of the electroscope. I have told you that here is the neutral conductor. We have the negative charges are 1, 2, 3. Then while the positive charges are what? 1, 2, 3. So they are equal. So it makes this cap here to be what? A neutral conductor. So you now bring nearer to it, not in contact. You now bring nearer to it now a negatively charged ebonite rod. Now what will be the observation? The positive charges are attracted towards the inducing charge. The positive charges are what? Attracted towards the inducing what? Charge. While the negative charges are repelled away from it, as in the diagram below. So you can see that these positive charges will now be attracted, all of them, towards parts of this cap of the electroscope, while the negative charge on F190 rod will repel the negative charges on this cap to this extreme. I follow it based on the fundamental law of what? Charges. Now what's up? Touch the cap of the electroscope as it hits it. Because you are standing on the ground, you touch it, the charges will now flow through your hand to the ground. That is earthly. Touch the cap of the electroscope as it hits it, while the inducing charge is still in what? Place. Is that okay? So if you now touch it, what will happen? There will be a momentary flow of the electrons from the cap of the electroscope to the what? Earth. There will be a momentary flow of the electrons. They will flow through your hand now from the cap of the electroscope to the what? Earth. Remove the earth connection and the inducing charge and observe that the positive charges will be spread around the electroscope. So when you now remove both the inducing charge and the earth connection, these charges will now spread around the what? Electroscope, thus leaving the electroscope positively what? Charged. So when you now remove it, what now remains is what? Positive charges, which can flow now down through this rod to the stem and what? The leaf, thereby getting the electroscope positively what? Charged. Now I want to look at how to charge an electroscope negatively. You have charged it positively. I want to look at now how to charge an electroscope what? Negatively. To charge an electroscope negatively, follow the above steps with the use of positive inducing charge. In this one here, we'll use ebonite, which is negatively what? Charged. In the next step, we're going to use a positive what? Positively charged glass rod. So to charge an electroscope negatively, you have to follow the above steps we have taken here with the use of what? A positively charged inducing charge. Is that okay? You follow the same steps we have done here and you get the same thing, which you can do on your own. Now, uses of a Goldleaf electroscope. What are the uses of a Goldleaf electroscope? Number one, it is used to detect charges, the presence of charges on an object. The electroscope consists of an earthed metal case. I've said it today that the metal case there is always earthed, so as to avoid much accumulation of what? Charges, apart from that coming from the cap of the electroscope. So the electroscope consists of an earthed metal case. Inside it, metal case. Inside it is a metal rod, which I have shown you today, which is connected to a metal plate. The metal rod is connected to a metal what? Plate. A piece of gold leaf is attached to the other end of the metal rod. When the metal plate becomes charged, the charge spreads out through the metal rod and the gold what? Leaf. Now, if you have it that metal disc there, or the brass plate, once it is charged, the charge spreads through the rod to the metal plate and then the gold what? Leaf, and they will have the same kind of what? Charges. The metal rod and the gold leaf gains the same charges, so the thin gold leaf repels from the rods and diverges. It will now repel from that what? It will now repel the glass plate, because they are having the same what? They are having the same what? Charges, so it will repel this. That will bring about the divergence of the leaf from the rod. The divergence of the gold leaf shows the presence of charges to the what? Gold leaf. Remember the fundamental law of charges, that like charges repel each other. So the plates there and the gold leaf, they have the same charges, so they will repel each other. So that will bring about divergence of or separation of the leaf from the plates. Number 2, it is used to distinguish between conductors and what? Insulators. It is used to distinguish between conductors, whether a material is a conductor or it is an what? Insulator. How does it do that? If a charged electroscope is in contact with a good conductor, the gold leaf will collapse rapidly. It will collapse rapidly, showing that the material is a good what? Conductor. So you have charged the electroscope either positively or negatively. So if you now bring a good conductor, if you now bring a good conductor in contact with it, now we'll have it that the observation will be that the gold leaf will do what? Collapse rapidly, showing that the material you have brought in contact with the cap is what? A good what? Conductor. When the cap is in contact with an insulator, you are unfortunate now with an insulator, there will be no change in the divergence of the leaf from the rod. So there will be no separation. Is that okay? Nothing will change in the divergence of that leaf from the rod. When the cap is in contact with a poor conductor, there will be a gradual collapse of the leaf, showing that it is a poor conductor. It can allow charges to pass through, but not, it will not allow much percentage of charges to pass through. It is a poor conductor. Means small quantity of charges can pass through it. So there will be a gradual collapse of the leaf, showing that it is a poor conductor. So through this, the Goldleaf Electroscope can be used to distinguish between conductors and what? Insulators. The electroscope can be used to determine the nature of the charges on a body. You can use it to determine the nature of the charges, whether positive or negative. How can that be done? If the electroscope is already charged positively, you've charged positively, and a positively charged body is brought near the cap of the leaf, what will happen? Divergence increases, because the same charge is coming. A charge of the same sign is coming from that object to the electroscope. So we'll have it that based on that fundamental law of charges, there will be repulsion. And so since there is a repulsion of the charges between each other, there will be increase in what? Divergence of the leaf from the stem. So if the charges are of opposite signs, the leaf divergence decreases. Is that okay? So through this, the electroscope can be used to determine the nature of the charges on a body, whether it is positive or what? Negative. Is that okay? Number 4, it is used to estimate the magnitude, that is the size of charge on a body. Here, a professional electroscope is calibrated to not only detect the static electricity, but also to determine the size of the charge on a body. So we'll not just use ordinary or manual electroscope, but here we use what is called professional electroscope, which is calibrated to detect both static electricity and determine the size of the charge on a body applied to it. You can see it here. So we have here as a cap, you can have the rod, the stem, the gold leaf. Now there's a calibration here to measure the quantity of charge coming to it. So we'll have this one as a professional electroscope. It can be used to estimate the magnitude or the size of charge on a body placed on the cap here. Now I want to go to the next subtopic, the lightning and lightning conductors. We don't see lightning on the cloud. How does it come about? Lightning occurs when charges build up in a cloud. We have it that when charges build up in a cloud, lightning can occur. When these pass from cloud to cloud or from cloud to the earth, a spark or a discharge is produced. The spark is seen as a very bright flash, which is called lightning. So we have it that when these charges are built up in the clouds, and they can pass from cloud to cloud or from the cloud to the earth, as a passing, there can be a discharge or a spark between them. And so when that spark it happens or occurs, it is seen as a very bright flash. And we call it what? Lightning. We call it what? Lightning. The large amount of energy released in this process rapidly expands the air through which the flash passes. So as it is passing through, energy is released. And the amount of energy released in this process, it rapidly or speedily expands the air through which the lightning is passing, or through which the flash is passing. And this produces a very loud sound, which is called what? Thunder. Is that okay? So lightning tends to strike tall trees or high buildings, which you are aware of that. And if this happens to a building, serious damage may be done. Serious damage may be done to it if a safe path is not provided for the discharge of those charges coming from the lightning. So to safeguard buildings from lightning discharge, a lightning conductor is provided. Is that okay? So we want to look at now lightning conductors and how it works and how it tries to protect the house from thunderstorm. The lightning conductor. The lightning conductor is found on top of a tall building. You can see here is a building. You can see this material here is known as lightning conductor. The lightning conductor is found on top of a tall building. It consists of a long vertical metal rods or conductor with sharp points. You can see it. You can see the rods. You can see the rods here with sharp points. And is connected to the earth through a metal plate. Example is the copper plate. And see it's connected to the ground rods. It is connected to the ground with a wire. It can be copper cable wire, copper plate. Yes. If a negatively charged thunder cloud is now moving on this negatively charged, is passing overhead the lightning conductor, mean above it, opposite it, directly opposite it. The cloud induces positive charges on the sharp points of the lightning conductor. It will induce, if a negatively charged thunder cloud is passing directly opposite the lightning conductor on your house, on the building there, the cloud induces positive charges on the sharp points of the lightning conductor. How will it do that? For instance, you have it that the lightning conductor there has both positive and negative charges. Now, if a negative charge is coming above it, directly opposite it, what will happen? It will repel away all the negative charges within that. And then what is now remaining now will be positive charges. Is that okay? So when I say it will not induce positive charges on the sharp points of the lightning conductor. Now the electrons in the lightning conductor are repelled to the earth through the metal plate or the cable. I've said it. The high concentration of the positive charges on the sharp points of the lightning conductor, the high concentration of the positive charges on the sharp points of the lightning conductor repel the protons in the air close to them. Now, if air around that lightning conductor has protons around it, which is now positive, now the positive charges on the lightning conductor will repel them away. Are you getting? So repel them away. To repel them. Repels the protons in the air close to them. Thus, generates a stream of protons which move towards the negatively charged cloud. To repel them, and they will be attracted now to the negatively charged cloud. And through this prevents accumulation of powerful charges on the building. Are you getting? So through this, it repels away charges that may accumulate within the building. So with these lightning conductors, some houses are protected. Houses that have this lightning conductor on them, they are protected from thunderstorm. So we'll have this to be the end of this topic. Before we'll call it a day, we want to evaluate or test our knowledge on what we've discussed so far. We'll now come to the next page on evaluation. The first question there says, define the term static electricity. Define the term static what? Electricity. Number 2, state the fundamental laws of charges. State the fundamental law of what? Charges. Number 3, list 3 ways of producing charges. Number 4, draw and label the Goldleaf Electroscope. Number 5, with a simple diagram, show how charges are distributed in a spherical conductor and a triangular shaped what? Conductor. Now I believe you must have finished answering the questions. We want to see the next page to guide us on what we've done, to know whether what we've written down is really correct. The first question you're asked to define the term static electricity. It's a type of electricity or electric charge that does not move from one point to another on the substance in which it is produced. Has been explained today, right? So check whether what you've written is correct. Now, number 2, the fundamental law of charges states that like or similar charges repel each other, while unlike charges attract each other. 3 ways of producing charges are, we have 1 by friction, by contacts, by electrostatic induction. Now, number 4 gives you a diagram of the Goldleaf Electroscope. We have here as the brass cap, you have here as the insulating plug, you have here the metal case, you have the brass rod, the gold leaf, and then the brass plate. This is the earth connection itself. This is a diagram showing the Goldleaf Electroscope. Finally, we'll have charge distribution on spherical conductors. We'll have this diagram to show that. Now, charge distribution on triangular shaped conductor, we'll have that. I believe that is what we've written down. Thank you very much. We've come to the end of this lesson. I hope there is no question. Is there any question? If there is no question, I'll call it today. We'll see you next time. Thank you very much.